Hello, today we are going to work on combinations. So yesterday we did permutations, and permutations use that capital P and PR. And the big thing about permutations that we need to remember is the idea that when we do permutations, order matters. Permutation, placement. All right. The next thing we look at past permutations is what we call combinations. And combinations, the two things we need to know about combinations is order does not matter. We have a combo, all right? So we are picking a group of people is how I see this. So a combo. Or if you think of pizza, right? If you have a combo pizza, they just throw all the ingredients on. It doesn't matter if they put the onions on first and then the peppers and then the sausage. It's just combo, all right? The other thing is we still can't have any repeats. So on any of those ones we did a couple days ago where we did license plate and we could repeat letters, you can't do those permutations and you can't do those combinations. So I'm thinking of using my calculator now to figure out the combination button. You saw it probably right below NPR, right? Was this little NCR. The N still stands for the same thing it did with the NPR, right? It's the total number we have. And the R is the number I'm picking. And we get it the same way. We got the NPR button. We hit math, we arrow over to the probability piece, and then you see on 3, you have NCR. Now, of course, you have to hit the number you want first, the N value. So if I'm doing 5, math, over, and then maybe I want to pick 2 things, right? I can hit enter, and that's my value. Now, when looking at combinations and permutations, we should think about the idea of which one's greater and which one's less, because it's helpful to think about that when you're having to list things. And if you think about it a little bit, if you have permutations, that means that if you get first place, second place, that's different than switching it up and maybe you got second place instead of first place. So combination is just grouping of people. So I could put 3 people together. Harry, Sally, and Joe is the same group as Joe, Harry, and Sally. But different if I give Harry first, then Joe, then Sally, right? So combinations will always be less than permutations. All right, so here's my situation. I got 4 kids standing in that Fiesta line again at lunch. An emergency comes up, and Mr. Donovan gets all 4 of those kids to come help. How many ways can he choose those 4 kids? He's just randomly grabbing them all. We're headed to the emergency. So we got 4 kids, and we're picking all 4. So if I do 4 choose 4 in my calculator, 4 math, probability, choose 4. Now some of you might know the answer to this already because when I hit enter, it's probably not going to be terribly shocking. We get 1. If you've only got 4 people and you're grouping all 4 of them, there's only one way to group everybody in one big group, right? So that answer is 1. Change it up a little bit. Maybe we get to the emergency situation. It turns out only 2 people are needed, so we send the other 2 back. How many ways do we still have those people? So again, we had 4 in line, and we only need 2 of them now. But Sally and Joe are the same as Joe and Sally, so that's why it's going to be a little bit less than the permutation number that we did yesterday. So 4, math, probability, choose, and 2, hit enter, and there are 6 ways to keep 2 kids back. All right, let's look at this situation. I have 6 books in my bag. And I'm going to take some of them with me to lunch. What do the following represent? So if I just have this big bag, what does 6 choose 6 mean? Okay, so I've got all these books, I'm putting them in the bag. The 6 means I have a total of 6 books. And this 6 means I'm taking all of them to lunch. So if I do 6 choose 6, how many ways are there to take 6 books? If you're taking all 6 of them, there's only going to be one way to do that. What about 6 choose 5? Okay, well, that means I have 6 books to choose from. And I am taking 5 to lunch. Okay, and so how do we get that number? We go 6, math, choose, and 5. Hit enter, and my answer is 6. All right. Well, what does 6 choose 2 mean? 6 choose 2, I can go get it as a number. 6 math, arrow over, choose 2, enter, I get 15. So that is telling me there are 15 different combinations out of my 6 books if I'm only taking 2 books. So there's 6 books, I picked 2 of them, and there's 15 different ways that I can have 2 of the 6 books. What does 6 choose 0 mean? Well, 6 choose 0 means I'm going to lunch to eat and not doing my homework, right? I didn't take a single book with me. So how many ways can I not take any books with me? 1 way. And again, you can go 6, math, over, choose, 0. I'm not taking any books. There's only 1 way to not take any books. All right. So here's the big deal. Can we tell when permutation is needed versus combination? And so you have to ask yourself every time you get to a situation, does order matter? It was easy yesterday because of course it mattered. That was the only thing we did was permutation. And if we only do a combination, then that would be easy too because you just know you're going to use combination. But looking at these different scenarios here, we want to be able to see, are they combinations or are they permutations? So if I look at the variety of them, let's just start with create a locker combination of 50 different numbers. Okay, so does it matter when I do my combination if I do 2, 4, 8, or can I just do any combination and get in? I think most of you say order matters on that one, so that is going to be a permutation. Announce medal winners in a race. So if you get first, second, third, right? Again, order matters, permutation. Scoop different flavors of ice cream into a cone. Now, on this one, this is kind of not really a very order specific situation. But the reality is if you're putting them on the cone, you're stacking them on top of each other. And so if you have chocolate on top and the vanilla on bottom, it actually is going to be different than putting the vanilla on top and the chocolate on bottom. So if you're scooping them into an ice cream cone, you're layering them, and so order is going to matter. But if you're just putting them into a bowl, then you just have this random bowl of all kinds of different ice cream. So that you can't tell the order. All right, how about, let's put some of these down here. If we create phone numbers with unique digits, we all have unique digits with our phone number, so we want to put that. With permutation, order definitely matters. What about 5 different boxes of cereal at the store? When I go to the register, does it matter? Different. And if just throwing them in, they're going to cost me the same no matter which order I put them in. Select 4 people from our class to go see Mr. Fink. Combination. Any 4 can go all at the same time. List courses on your class schedule. Okay, well, it makes a difference if you take math in the morning versus math in the afternoon. So that is different. Permutation. Assign 30 students to tables in the IMC. Again, if you're just grouping them at tables, that's just going to be a combination. Simplify an expression. If we look at that, does order matter when you simplify an expression? Yeah, right? You need to do your PEMDAS. So I'm going to put that one over here with permutation. All right, so that is all I have for you today. I want you to take a look at the back of this worksheet. the Did You Hear About worksheet, and you are going to complete it and do animal cracks. Once you finish that, there is a worksheet that is, you have to pick between combinations and permutations. And I will see you on Monday. Have a good weekend.